Okay, ladies and gentlemen, this is the last sessions of the EMM robotics today, and well, we had 3 days of hard work on robotics and mechatronics there, and for this afternoon, well, we started the EMM with the French Ministry of the Industry, and we will finish the EMM with the Pope of Research in robotics in France. So I'm very happy to have Philippe Bidot here today. We'll give you some highlights of research in robotics in France and in Europe, and some of his ideas of what could be the future. So, Philippe, you have the floor and the afternoon.
Okay. I didn't know I have to give this presentation in English, so my slides are in French, and more than that, it's a sort of improvisation, because what I'd like to do right now with you is to try to see what we could do together in the next future, in the very next future, in the framework of what you have probably heard about, which is the robot. How do we translate France Robot Initiative? Our French initiative in robotics. Okay. Just for an introduction, I will not talk about very specific things, but try to give you an overview of what is going on in robotics in France, not in my lab, in all the labs which are related with what we call the GDR, which is a sort of club of academic people in connection with industrial partners. We try to push innovation from what we develop in research with them, and I will just give you an overview of what are our main research topics, research fields, and where you can grasp things which can be translated into innovations in the field of robotics. Before that, I'd like to, I will start by a short story about robotics, and maybe I can, do you have a mobile microphone, or? It's, this one is fine. Yes. This one is fine. Okay. Maybe you have already seen this movie, which is about. So you cannot hear. Maybe I can. No, I will not. Okay, so these are the two first robots which have been developed in the early 14th, more than 70 years ago. The idea was to create animates for the Universal Exposition, which took place in New York in 1940, and the first idea was to promote the use of electrical actuators to drive those very rustic, simple machines. But the first robot was bio-inspired in some sense. I want to show you also the first industrial robot which has been developed by this guy, George Devol, a few years after, in the early 15th. And the first deployment of this robot, which was a very simple but programmable robot, has been done in a small factory for the manipulation of heavy parts. And the idea by that time was to offer a technology for increasing the productivity in some sense. And the first limitations of those technologies have been observed very soon, and it suggested the development of research activities in what we call the field of robotics. And the main question was to be able, by using this kind of machine, to be able to take into account variations in the environments and being able to deal with different kind of parts to make that those robots could be more flexible in their use and in their deployment. And we have got few years after, at the beginning of the 80s, the first program in robotics in France, which has been set up by the initiative of the CNRS, which is one of the national research center in France. And the guy you see here is George Gerard, who passed over a few weeks ago. And he was the first promoter, and then he drove this program during 5 years, and it has been the first steps in robotics in research in France. And this other guy, Jean Vertu, was also someone very well known and a sort of pioneer in the field of robotics. He was an engineer at CEA, and he was the first guy to develop what we call telemanipulators. And until right now, we are still using those technologies in nuclear power plants, and we have a strong industry in telemanipulation, which is mainly because we have got those pioneers in the field of robotics and telerobotics. Short story. So from the 16th to the mid-17th, I say we, at an international level, we have developed programmable manipulators for different kind of application in industry. And the main purpose of those manipulators was to be able to drive the end effector along complex trajectories, programmable trajectories, and they were not able by that time to take into account any variation in their environment. During all these 20 years, it has been mainly the robotics has been mainly dedicated to industry, car industry, but with the aim to produce motion generator and, in some case, force generators. So these are the technologies which was available by that time at the beginning of the 70s. So those technologies were very rude and very simple. you probably recognize the famous robot called a Puma, which is a 6-axis robot, which decouple the motion of the wrist and the motion of the positioning system, which is based on the first 3 axes. So those technologies were very simple at that time. 10 years after. I will skip this movie, which is a little bit. Maybe I can leave it, but let's. I will skip it because it's too long. And in the 80s, we have pushed the development of more sophisticated manipulators, which was able to take into account, in some sense, variations in the environment. And one of the first things we did was to develop software for offline programmation of the systems, to take into account different configurations in the environment and being able to program the trajectories of the system to take into account those variations. So still the technologies were very simple, but it was the first steps in the augmentation of the manipulator capabilities by adding software, making that they could take into account variations in their environments. In the 90s was the years for the first success stories in robotics. You probably all know the Aibo dog from Sony. You have also the Canadam, which is a very system which is quite well known, which was used for the manipulation on the space shuttles, and many, I would say many, but not so many successful stories has been noticed in this period, and these are the technologies which are more common. The Da Vinci robot, which is deployed in France, for instance. We have about 50 of them in France, in hospitals. The Roomba robot was those cleaning robots, which are largely sold by different companies, and the Asimo robot, which is what we could say the most illustrative example of what we can do in terms of robotics today. Most advanced technologies are integrated in this system. And what we have to deal with right now is this kind of problem, which is a problem with the adaptation of the behaviors of system with the dynamic of the environment he has to deal with. And another dimension which is also critical is the security in those systems, which have to be guaranteed to be able to deploy those technologies in our personal environments without by dealing with the risk in this in troubles in their functioning. So those two particular dimensions are considered in the development or in the deployment of the research, not only in France, but also at an international level. What we are doing in terms of research is to produce knowledge which are, I would say, quite specific to the domain to offer paradigms being able to give solutions for the synthesis, for the structural and also the behavior synthesis of those systems dealing with complexity, making that they can get adaptive behaviors and secure also behaviors. And for that, we rely on, on engineering sciences, information sciences, but also since a few years, a decade, on cognitive sciences and life sciences. And this is quite common at an international level. Okay, so what we are doing in terms of research is illustrated here, and it is not a complete list. I will give you a more detailed overview of what we are doing in France in terms of research, but we are dealing with the synthesis of complex mechanisms by using softwares. We are dealing with the control of high mobility system, which include redundancy to be able to give more flexible helpers for the different kind of purposes in industrial processes and so on. We are also considering a very complex activity, which is the bipolar locomotion, which makes that we have to deal with the postural stability of those systems with respect to different kind of perturbations. And also the planification of the activities of the systems to make that we can avoid to program them in details, but making that they can be controlled in a sort of goal-driven way. I'm going to switch to my other presentation. Okay, so the French research community is quite large and in robotics. I will give you some, it is about something like 60 research teams in different universities, research centers, but it is one of the stronger at an international level. Maybe the third or the fourth compared to the others, which are the US, Japan, and maybe the Germany. So we have set up this GDR 7 years ago now to make that we can have a system to create synergies in between the different researchers and different research activities in the different teams. So this was the first idea, the main aim to make that we can create a sort of animation by using different kind of instruments which are quite basic and common. Conferences, workshops, the production of documents, roadmaps, the dissemination of very specific scientific innovations or results, or technical innovations. And also the dissemination of the educational material which was produced by the different actors. So today it's 60 research teams in different institutions, and about 1,300 members, researchers, of course, for maybe more than half of them, but others are PhDs and masters with specialties in robotics. This is a very simplistic overview of the distribution of the community over the Hexagon, France. So we have a first big community which is located in Paris and its region. Another one which is here. Oops, sorry. Which is close to, which is in Toulouse, in south of France, Montpellier, Lyon, Strasbourg, Rennes, Nantes are the main locations for our community. And all these researchers are in small teams in the majority, and it is strictly necessary to make that we can have a sort of network to facilitate the exchanges at least a national level. So synergies in between the research teams is the first aim, and being able to develop also collaborative research with the industrial actors is another motivation for having this GDR. It allows also to promote at an international level our activities through different kind of instruments. And we have, since 3 years now, tried to organize our experimental activities based on national platforms which are linked together in a network, which are accessible to the industrial partners who want to develop collaborative activities. So if you want to join the GDR, it's very simple. You just have to this was the old site, but our website is quite, the actual one is quite similar. So you have to click here, s'inscrire. It is in French. And you will have a password to access to those services and different kind of documents. We produce documents which are, for some of them, in English for communication at an international level. And those documents consider the activities we are developing in those different working groups, which gives a sort of distribution of the research activities in France, and which says where are our main interests, where are our main equipments also, and how we can also help in some sense the industrial actors who want to develop innovations in those different domains. So our research activities at the national level, its role is split in, I would say, or in 8 main domains. We are considering robotics for health, for we'll come back. So we are considering applications for to help therapeutic gesture and rehabilitation. I would say that maybe 30, 40 people are working in this domain in France. We are considering, of course, fundamental aspects, but also technological aspects, and we are developing also experimental activities in different frameworks, and mainly by involving practitioners in those experimental activities. We have a strong interest in autonomous vehicles for different kind of use, for evolution on off-road vehicles, but also drones, so yeah, but what's the name for naval? There is a specific name, I guess, for that. And the sea robotics, all these domains are covered by our community, and I think that this is maybe the most important part of our research in France, which is dedicated to those systems. Once again, we have fundamental research in this domain, but we are mainly involved in localization, cartography, interpretation of different kind of situations, the control of these systems in the different kind of environments, and the communication for their use in fleets, for instance. We have a smaller community on manipulation, but which is still very active, and I think that that is something which will be very important for the deployment of our national robot initiative, which is, as maybe you have heard, which will be dedicated in partially for increasing the productivity in small and medium companies. So manipulation is one of the major activities, and I guess that this community will be involved in this kind of in this part of the plan. We are developing systems, grippers, sensors, but also specific systems for micro and nano manipulations, making that those systems can be used in very interactive ways. These are examples of the national equipments we offer to our activities in the micro manipulation domain. We have also a strong interest in the development of control architectures, and most of our production is offered as open software by the different institutes which are involved in those developments. And those software are accessible through our website at this. If you go to this link, you will get an exhaustive description of what is produced by our research teams and offer as open softwares. Interactions for more day life activities, interactions with the users. Personal robotics is a big also research domain where we focus on interfaces for multimodal interactions, including gesture, posture recognition, expression recognition, but also physical interactions through haptic devices and so on. So we have also a very strong activity in this specific domain, and as you have also heard, this will be a part, one of the main part of the French robot initiative. We will try by using those research results to be able to reach innovations being used in day life activities in the next few years. And so we are also considering the design of those systems by using methodologies specific for complex architectures, including optimization processes and so on, but this is quite classic for all the design of machines. We have several teams who are involved in humanoids robotics, and what you have seen here, the exoskeleton, which is now a product, results from our research activities, which has been initiated at maybe 10 years ago, mainly by the development of research collaborations with the Japan around the HRP2. Which is still existing right now, not the exact HRP2, but this cooperation. And a last research activity which is dedicated to the knowledge, the use of the knowledge we can have on the cognitive and neuro sciences for the perception, for the action, to try to translate this knowledge into advances for more autonomy and increase the performances of the system by adding, for instance, learning capabilities. Okay, this gives you a very broad overview of what we are doing at national level, and what we are considering in the next robot initiative relies on not all, but part of this research. So as industrial actors, if you are, or are as end users, you are deeply invited to solicitate this community to try to take advantage of those research activities for creating innovative products in personal robotics, in industrial robotics, in mobile systems for different kind of, in open field activities, and so on. So the most simple way to make a contact with this community is to go to our website, which is here, and you can send messages, address the community with your questions, and if you go a little bit further, you could be able to use part of our equipments which are offered to collaborative research deployed by not the GDR but by specific actors which are belonging also to the GDR. We organize the activities of the experimental activities in such a way that you can take to make use you can make use of those equipments which have been bought by our national with a national support. I can take questions or comments if there are some.
So, thank you, Philippe. So, as the first question is perhaps the most difficult, I will ask the first question. There will be a question in the room. My questions, well, it's perhaps a very simple question. The answer may be perhaps more difficult. If you have to summarize, what could be the 3 main challenges for research in robotics in your minds? What will be the 3 main challenges?
You're speaking about research or the use of research for innovation?
Or research for innovation, yes, okay.
Only 3?
Oh, if you prefer 2.
2? Thanks. No, thanks. Difficult to answer. The first challenge, I guess, is to make that we could deal with, as I mentioned, to the dynamic of the environment, its evolution, and the adaptation of the system to the variation of the environment is still a question in terms of research. We have some bricks to answer this complex question, but this is still a question for researchers. And when I say adaptation is a long-term adaptation, it's not a local variation. I mean, if I want to grasp something which is not located here, but here, it's quite simple. If I want to reach a location with large variation in the environment, I have to find a way to reach a place among the obstacles, among dynamical obstacles, and this is still a question for research. Another critical question, which is not so much addressed right now in France, but which starts to be integrated in our research activities, is to make that we can guarantee the security of these systems and being able to deploy them in human environments without, I would not say without, but by limiting the risk. And these are very critical questions for robotics today and for its deployment in a very next future. Many other challenges. Learning is a very active domain, but we have still many things to discover, to make. We have large progress to produce, and this will be also a way for adaptation for the system. If I have only 2 slots, I would say that.
Thank you. Question in the rooms? Still alive? No questions? It was totally clear or totally too difficult? No, clear, I think. So, oh yes, there is a question.
Hello, I'm a computer engineer and I'm interested in robotics. So I don't know how to focus to learn electronics, mechanics and stuff. Can I contribute to this kind of projects you just presented, robotics and GDR robotics, to learn and contribute to projects?
Of course. I mean, the GDR is not it's not a project. It's a kind of network. So you can be involved in this network and contribute to by your activities to the increase in the knowledge and in the innovation. It's quite simple. I mean, you have to register and you will become a member and you will be able to participate to the various workshops. Something like 20 are organized each year on different topics, and you can bring your knowledge, you can exchange with the others. I mean, it's a sort of national platform for exchanges, and we try to make use of specific equipments for developing proof of concepts and make that you can offer a way for simplify the innovation in different domains. Sorry?
Where do you meet? You said
in different locations. Okay. We have physical meetings in different locations. Some of them are organized in Paris, but others in other places. We sometimes go to visit industrial partners, and we organize this as a meeting in their place. Different places.
Okay. And you have the schedule on the website for the different events. Okay, thank you very much.
Another question? Yes.
Just complete the answer to say that you have also job offers on the newsletter of the GDR, which may be of interest for some people here.
Thank you.
Thank you. So, okay. Philippe, thank you very much for this
very welcome
presentation. So, this is this session so closed. The EMM robotics of this year. So we would like to thank you for to be there during 1, 2, or 3 days. You have still 2 hours to visit the exhibitions, and our next EMM will be in September in Toulouse, which will be dedicated to what we call aeromotive, mixed of automotive and aeronautics, with a part also dedicated to robotics. And we will have a visit of the LAS during this session. So if you need information, just outside you have the small first paper to present the next EMM. And also if you have a business card, do not forget to leave it there, because you have a possibility to win a small computer, a tablet. So have a nice afternoon and of the afternoon, and a nice exhibition. See you in Toulouse if you want. Bye-bye.